For next question is given that a spherical metal ball of mass zero point 0.5 kg moving with the speed of zero point 0.5 meter per second on a smooth linear horizontal track collides hand on with another ball. So let's say these are two balls, spherical balls, and they of same mass, and they collide with one another. One is moving with a speed of zero point 0.5 meter per second, and the other ball is at rest. So let this be. So let this be ball A and this be ball B, and it's given that uh, they both have same mass. So M1 is zero point 0.5 kg, and mass of the second ball is also 0.5 kg. Now this is moving with the velocity of this speed of this ball B, initial speed GUA, and this is moving with a velocity of zero point 0.5 meter per second. And we are going to consider the direction in the right as positive and direction in the left as negative. So this was at rest, so u2 is equal to 0. Now both these A and B collide, and because they are of the same mass, so we know that when bodies of same mass collide with each other, so and if one is at rest, so the second body moves with the velocity. So this will move with a velocity of zero point 0.5 meter per second, and this will come to rest. So that means this will come to rest after collision, and this will start moving with the velocity of, so this will acquire the velocity u1 of body A. So this will come to rest, that is the velocity of A will be 0, and the velocity of the second body, okay, we have considered it B, so let it be V. So let this be mass A and mass B. So this is mass A, this is mass B, this is velocity V will be equal to velocity, initial velocity of A. Final velocity of V will be equal to initial velocity of ball A. That is, final velocity of V will be 0.5 meters per second. This will come to rest. So let's try to find out. It's given that the collision is perfectly elastic. So for that, the coefficient of restitution is 1, and the coefficient of restitution is given by velocity of separation by the velocity of a move, that is u1 minus u2 is equal to 1. Now v2, the direction of v2 is positive, and v1, this will come to this direction. So let's say this is negative, and u1 minus u2. So u1 is 0.5 and u2 is 0. So we have this equation. So this is v2 plus v1 is equal to 0.5. Or I can write it as this one A and B. So this is B minus A and A minus B. So this is B A, which gives the velocity of A plus velocity of B is equal to 0.5 meter per second. Okay, so we have got this one equation, and let's use the uh, law of conservation of momentum. So according to law of conservation of momentum, so according to law of conservation of momentum, initial momentum of the two bodies should be equal to the final momentum, which is MA MAB plus MBB. Now, Let's put in the respective values. So the mass of the two bodies is same. So this is zero point 0.5 into initial velocity is zero point 0.5. Mass of the second body is 5, zero point 0.5. Its initial velocity was 0, was at rest. This is zero point 0.5 into VA we have to find out, plus this is zero point 0.5 and final velocity we have to find out. So because we have taken assume that this body first body will come to the left hand side, so this is negative, so this is 0.25 and zero point 0.5 into 0 is 0, so this is negative 0.5 into VA plus zero point 0.5 into V. Okay, so if I take 0.5 common here, so this is negative VA plus, which gives me zero point 0.5. So finally I have this equation VB minus VA, or let me just write it as minus VA plus VB is equal to zero point 0.5. That is the second set of equation. And let's try to solve these two set of equations. So I'm going to add two equations. So by adding these two equations, this gets cancelled. So 2 times VB is equal to 1 and velocity, final velocity of B is equal to 1 by 2, which is zero point 0.5 meter per second. And if I put here the final velocity of V, which is zero point 0.5, so this gets cancelled. So that means the velocity of V is 0. So the first wall will come to rest after the collision, and the second wall will move with the initial velocity of first wall. Thank you for watching.